Today we look at option pricing for a stock index. So the question reads, a stock index is currently $1,500. Its volatility is 18%. The risk-free rate is 4% per year for all maturities, and the dividend yield on the index is 2.5%. Calculate values for U, D, and P when a 6-month time step is used. What's the value of a 12-month European put option with a strike price of 1,480 given by two-step binomial tree? So as you can see here, we have to adjust our formulas for the dividend yield. The dividend yield in our case is denoted by Q. And as you can see, it's going to be subtracting the risk-free rate, R. So first thing to do is let's write down what we know for this exercise. We know the volatility, denoted by sigma, is 18%. We know the risk-free rate is 4%. And it says the dividend yield is 2.5%. Then a 6-month time step is used. The time step is denoted by this, and because it's a 6-month time step, remember the reference time period is 1 year. Therefore, this would be 0.5. Okay, so 6 months divided by 12, because there's 12 months in a year. 6 divided by 12 is 0.5. And finally, we know that the initial stock price, or stock index price in this case, is 1,500, and now we know the strike price, denoted by K, is 1,480. And remember, this is a European put option. Okay, so first thing to do is to find out U and D so we can construct the binomial tree. So we're going to use these formulas. So U is going to be E to the power of sigma, which is 18%. The volatility in decimal places is 0.18 times the square root of the time step, which is 0.5. If you plug this into the calculator, you should get that U is 1.136. Then D is the same thing, but with minus the volatility. So E to the power of minus the volatility times square root of 0.5. If you plug this into the calculator, you should get 0.880. Okay. Let's construct the binomial tree now. So we know the stock index starts at 8,500. Then it goes up or down. And so remember, the definition for U is the magnitude of an up jump. So by how much the value goes up of the stock index, and D is the magnitude of a down jump. So by how much it goes down. So in order to find out the stock index value in the high state, so when it's gone up, we do 1,500 times U, which is 1.136. And if we do that, we should get 1,704. To find out the stock index value when it's gone down, we do 1,500 times D, which is 0.88 in our case, and this should give us 1,320. Perfect. So now we have a one-step binomial tree. However, this is a two-step, so we keep going one more time. Okay, and now we do the same. 1,704 times U gives us 1,935.744. 1,704 times D gives us 1,499.52. Remember, you can get this result by doing 1,320 times U as well. You choose which to do. And finally, 1320 times D again. This gives us 1161.6. Excellent. So now we have the two-step binomial tree. Now remember, below the stock index value, we write what the option values stand for. So the current put option value is F, what we're trying to find out. And then the option value here is FUU, because it's gone up twice. Here's FUD, or FDU, you choose which one. And finally FDD, because it's gone down twice. Okay. Before we proceed, we now need to find out the probability. The probability is the probability of the stock index value going up. So for this, we use the formula that we have. So P is equal to E to the power of the risk-free rate, which is 4%, decimal places, 0.04, minus the dividend yield, 0.025, times the time step, which is 0.5, and then this whole thing minus D, which we said is 0.88, over U minus D. And if you plug this into the calculator, we should get that P is equal to 0.498. So this is the probability of the value going up. And then the probability of the value going down is 1 minus P, which is equal to 0.502. Excellent. Okay, so now that we have all the necessary values and information, we can use the formula for a two-step binomial tree in order to find out the current value of the put option. Now, before doing that, we need to find out the option values at the last period, because remember, this is a European option. A European option can only be exercised at expiration, so the last period. And also, remember, this is a put option. A put option means the investor makes money when the strike price is higher than the stock price, or the stock index price in this case. So for instance, let's take FUU. Here the stock index price is 1,935 and the strike price is 1,480. So as you can see, the investor is losing money. Therefore, in this case, the investor wouldn't exercise the option. The option gives you an option gives you the right, not the obligation, to exercise. Therefore, in this case, because the investor is losing money, the option is worthless. So FUU is equals to 0. What about FUD? Again, here the stock index price is 1,499, which is higher than the strike price, which means again, the investor is losing money. Therefore, the investor wouldn't exercise the option, so it's worthless. And finally, FDD, in this case, the investor is making money because the stock index value or price is lower than the strike price. So to be more precise, the investor in this case is making 1,480, the strike price, minus the stock index price, which is 1,161.6. Okay. And this gives us 318.4. Okay, excellent. So now we have the option values that we need in order to complete the formula. So this was 318.4. Okay, so now we need to use this formula to go directly back and find the current European put option value. So F is going to be E to the power of minus 2, open brackets, risk-free rate, which is 4%, decimal places, minus the dividend yield, times the time step, which is 0.5, and then we open brackets. We have p squared, which is 0.498, times FUU, which is 0, plus 2 times p, times 1 minus p, which we said is 0.502, times FUD, which we said is 0, plus 1 minus p squared, so 0.502 squared, times FDD, which is 318.4. And we close brackets. Remember, anything times 0 is 0, therefore we can forget about this part and this whole part as well. And so we're left with f is equal to e to the power of minus 2 times 0.04 minus 0.025 times 0.5, and we open brackets, 0.502 squared times 318.4. And if you plug this into the calculator, you should get that f is equal to 79.03. Okay? Therefore, the current European put option value is equal to 79.03. And this is the final answer that you need.